Professor Ip, good to see you again.
Good to see you.
Congratulations.
Thank you.
Plasmark AD, this test can bring people with accuracy to test Alzheimer as high as 96%. Wow. Do you know you have saved a lot of lives and a lot of families?
Yes.
So tell me more about it, how it works.
So my research team, we developed this blood test that can provide an early diagnosis of Alzheimer's disease. So for the disease, actually, there are changes in the brain pathology many years before the onset of the clinical symptoms. So we work hard to develop this blood test that requires a very small amount of blood, like 1 drop of blood.
Yeah.
We'll be able to perform the test and gives a very accurate diagnosis of the condition of the individual. For example, whether the individual is healthy or has low risk or medium risk or high risk of getting the disease years later, like 5 to 10 years later.
Wow.
So the blood test is highly accurate, 96% for Alzheimer's disease. And very recently, we actually can provide diagnosis even earlier than Alzheimer's disease. For example, if the individual has mild cognitive impairment, our blood test can also provide the diagnosis, with an accuracy of about 87%.
Wow, that's really amazing, because this is a major disease for a human being, I think, for anyone age above 40 years old. I'm sure many people will come up to you and say, Professor, how can I get tested? Actually, I want to get tested just to prevent.
Yeah, actually, the test is now available in the clinics in Hong Kong, and we have formed a startup. The university actually encouraged the establishment of startups. So we emphasize and we support innovation and entrepreneurship since the establishment of the university. So we have a technology transfer center at the university that arranged that, to help us take our research findings from the bench to bedside. So we can take our research findings and take it out of the lab and then implement it and provide benefit to society.
When the relatives notice that their grandma, grandpa, or their parents not be able to recognize them.
Yes.
That is really a very heartbreaking moment.
Yes. It's really, our passion, right?
Yeah.
How can we contribute to society? How can we leverage our research findings and take it further to translate our findings to, providing, either a diagnosis or some treatment options for the afflicted patients.
Because I'm already getting emotional. I mean, just by talking about it,
Yeah, because it really, for this type of disease, it's not just affecting the patients, it's affecting the families,
and all
the caretakers and
Indeed.
loved ones. And for this disease, it's particularly, difficult, heartbreaking because of the memory loss,
right.
And so, I mean, I've been working in the neuroscience fields for decades, but I think it was like 8 or 9 years ago, I told myself, I said, I really need to do my best to contribute to this devastating disease,
right.
In part because of the prevalence. So globally, there are about 40 million Alzheimer's disease patients, and it's projected to exceed 100 million by 2050. So this is a very, very substantial number. And because of the aging population globally, the number is bound to increase, right?
But Professor, what you said, from bench to bedside, it's not easy. It's not like just your work as a researcher.
Yes.
You have to build a whole ecosystem in order to make people have access to it, like common folks. How did that happen?
Yeah, so for this particular blood test, it actually started off as my PhD student's thesis project. So he actually did a very comprehensive study. So our group was the first research group that conducted such a comprehensive study to look at the blood proteins, comparing Alzheimer's disease patients with the healthy control. So when we look at the differences in the expression of these blood proteins, we found that a few hundred of the blood proteins out of 1,100 blood proteins, they were altered in the blood of the Alzheimer's disease patients. Then we proceeded to group them into different clusters,
right.
and then use big data analysis to identify 21 proteins that we call biomarkers. So these are blood biomarkers that will allow us to come up with a method to identify the Alzheimer's disease patients. So,
but to nail down the 21, it's already a big process,
yes,
isn't it?
Yes.
How did you discover them or identify them? Were they by accident, or actually you were doing tests on every one of those? I think that's a tremendous amount of work.
Right. So what we did was we used big data analysis to identify these proteins that are regulated or they are changed during the disease progression. And so that gave us, the clues that these are the proteins that represent the different biological pathways.
Right.
Okay, so leveraging, the identification of these proteins, we validated them based on more than 2,000 individuals.
Wow.
In Hong Kong through collaboration with clinicians in the hospitals.
But that is only nailing down the 21 proteins.
Yes.
Not to mention getting the accuracy rate as high as 96.
Yes.
That is another long process,
That's
I would
right.
assume.
Yes. I think based on the research that we did, we identified these proteins that are closely associated with the disease, right? And through these proteins, we actually can get more insight about the disease mechanisms.
Right.
So that will lead us to, looking into ways to provide treatment. But based on the proteins alone, we can already build this kind of protocol or methodology that allow us to develop the blood tests with high accuracy. But how do we take this from a laboratory to bedside? So this would require optimizing the test and also validating the test, and then setting up this company that will be in charge of implementing the blood tests for the community.
Right.
So that's the other part of the ecosystem. So for the ecosystem to be complete, it requires different components. First, we need to have funding, right, to allow us to do the research. And for this, I really, I'm grateful to the funding support from the central government, from the Hong Kong government, and also from the, setting up a center in Hong Kong called the Hong Kong Center for Neurodegenerative Diseases. So all this funding support and also the platform that was set up over the years, including the State Laboratory of Molecular Neuroscience, to allow us to do the work.
That's the first step, of course, and then doing the hard work.
By students, right? Talented researchers, including students and staff in the lab.
And
so
patients,
they work as a team. Exactly. So patients, and for this, since HKUST does not have a medical school, so I had to collaborate with clinicians, and they are very, very supportive.
I see.
And we work together as a team. So researchers and clinicians working together, and based on the samples they provide to our research team, we could do the validation, we could develop the tests, right? So again, funding, researchers, including students, scientists and clinicians, and then the translation part is critical, and that is achieved, through forming startups, university startup, to help us develop the test to one that can be implemented,
right?
For the society.
Right. What does it say to you when China makes very clearly that new quality productive forces will be the key for future economic development?
Yes.
Would that help you to connect the dots that you've already been thinking for years as an educator and as a scientist? How can you tap into the advantages that there is such a momentum now?
Yeah. No, I'm truly excited about this new quality productive forces, because it is so visionary, and it is something that, again, higher education sectors can really contribute. Because for this to happen, we have to train talents, we have to have the right ecosystem, and we have to look into the future, right? What kind of technologies can really contribute to that? So this is perfect for university to contribute, because
right on time.
Yeah, because this is exactly what we are doing, right? So we have to be innovative in our curriculum design. How do we train our students? So, for example, we launch Measure Plus X, and X means any emerging technology. It can be AI, it can be anything.
Wow.
So we have launched that, and the students love it, because they have the opportunity to
think
learn
and to imagine.
Think. Exactly. So now with ChatGPT, we said, well, we don't just expect students to memorize what they learn in class, but they have to learn how to think.
Today is the International Women's Day, Professor Ye. I really wonder, for a female scientist, for a great president of a university, for one who has been trying to connect the dots and bring the best talent to work for humans' benefits.
Yes.
What would be the best gift for you for the day?
I really would like to see more women joining the scientific community. Being the first female university president in Hong Kong after more than 100 years, I'm very much honored, and I really hope that there will be more to come. I think we can make so much contributions to the world.
Together.
Together.
Yes.
Yes.
Professor Ye, I wish that hope come true, and happy International Women's Day to you.
Thank you.
Thank you so much.